All right, everyone. So this is the video that's going to combine one-step dimensional analysis using Avogadro's number and molar mass in the same video. So remember, we know that 1 mole of anything is equal to 6.02 times 10 to the 23 particles. And that could mean that it's atoms, formula units, molecules. It kind of depends on whether or not you're talking about a single element, something that's ionic, or something that's covalent. Depending on what you want. But we also know that 1 mole is equal to the molar mass in grams. So remember that you can write each of these equalities as conversion factors. And it's just going to kind of depend on which one or both you need to use. So in example 1, it says how many grams of water are in 3 moles of water. So what we want to do is we want to label what's given to us and what we are trying to find. So we know that we are given 3 moles of water, H2O. And we're trying to find grams of water because it says how many and then grams. So grams is our unit, water. So what we do is we check a couple of things first. We look at our first unit. Because this is moles, we do not have to do anything. We just do nothing. There's nothing special there. Then we compare our chemicals. It's H2O in both of these cases. And so because they're the same, that means we do nothing. So far, nothing to do. But then we look here. And anytime we find grams, that means we're going to need our molar mass. Now, some of you might know the molar mass of water off the top of your head if we've calculated it enough, but otherwise we'll have to use the skill that we learned in our other video about how to calculate molar mass to actually do the calculation. So we have hydrogen and oxygen. There are 2 hydrogens and 1 oxygen in water, and we multiply them by their mass from the periodic table. Water is 1.01 and oxygen has a mass of 16. So we multiply across and we get 2.02 for hydrogen and 16.00 for oxygen. We add them all together to get the total for water and we get 18.02 grams per mole. And so we know that that can be written as a conversion factor as either 18.02 grams of water over 1 mole of water, or it can be written as the reverse. So the numerator and denominator can swap places. And I'm just going to show the arrows there to show that we can flip them. So since we know that molar mass is the only conversion factor we need because the chemicals were the same, moles, we didn't have to do anything. The grams and what we're trying to find indicates we need molar mass. We'll just set up our t-chart. So we put our given in our t-chart first. So we have 3 moles of H2O. And because we have moles of H2O in our numerator, that means moles of H2O will also have to be in the denominator of whichever conversion factor I use next. And since I only need Avogadro's number, not Avogadro's number, molar mass, and the way we had written it already has moles of water in the denominator, I can write it just like that with 1 mole of H2O at the bottom and 18.02 grams of H2O at the top. And we see that moles of water will cancel out with moles of water. Grams of water matches what we're trying to find. So that means we're ready to put it in our calculator. And so what we'll do is we will multiply by what is at the top and divide by our denominator. So in that case, this would be 3 times 18.02 divided by 1, which is 54.06. And since there was only one significant figure in this problem, we will round that off to 55, let's see, the easiest way to put that at 1 sig fig, well, that would just make it 50. Yeah, that would just make it 50 grams of water. Which I know it's kind of like, oh, that's changing it a lot, but remember, don't put your decimal there. We don't have a super accurate thing, but since we're multiplying, 3 is just one significant figure, so it'll just be 50 grams of H2O. And so that example, we used molar mass as our conversion factor. Let's take a look at example number 2. So example number 2 says, what is the number of moles found in 5.4 times 10 to the 22 atoms of copper? So here, if we look at what is given to us, we have 5.4 times 10 to the 22 atoms of copper, and we are trying to find the number of moles. And because it doesn't specify what chemical, we're going to assume that it's the same. So it's going to be moles of copper. So again, we check our given and what we're trying to find to map out our situation. So atoms is one of our words that we use for particles. So this tells us that I'll need Avogadro's number in my problem. The fact that it is copper in both what I'm given and what I'm trying to find means that I do nothing because they're the same. And since this says moles, I again have to do nothing. Now, you might be wondering, why is Miss Nichols writing do nothing? Why is she checking the chemicals? Because guess what? At this moment, those are the same, or we're not doing anything, but in future lessons and future videos, that will not always be the case. So I want you to get into some good habits now while we're learning. So Avogadro's number, we know we're going to need that, so let's kind of write down what that looks like as a conversion factor. So that would be 6.02 times 10 to the 23 atoms of copper over 1 mole of copper, or it can be the reverse. It just kind of depends on how we set up our problem. So when we set up our T-chart, we're going to take what's given to us and put it in there first. So we have 5.4 times 10 to the 22 atoms of copper. Now, because atoms of copper is in the numerator, that means it also needs to be in the denominator. And so in order to do that, we are going to need to flip this conversion factor here. That way, 6.02 times 10 to the 23 atoms are at the bottom, and our 1 mole of copper is at the top. And when we do this, we multiply by what's at the top, and we divide by our denominator. So in our calculator, that would be 5.4 EE22, because I use the EE function on my calculator. Remember, if you're not using that, make sure you put any number in scientific notation in parentheses times 1 divided by 6.02 EE23. And again, I'm only writing this down because this is a video and I'm trying to teach you. If you're doing this at home, you don't have to write this down on your paper, but if you're afraid of making a mistake and this is a quiz or a test or something, showing exactly the way you're putting it into the calculator can help get you partial credit and things like that if all you did was make a mistake in your calculator but you knew how to put it there. So when we do this, we get 0.08970009967 in our calculator, but there are 2 significant figures in our given, so we're going to need that in our rounded answer as well. So we're going to have 0.090, because remember, 89, this 7 makes the 9 round up to 90. So this 0 is significant, but these are not because they're leading zeros. So we have 0.090 moles of copper as our final answer. And so you can use both molar mass and Avogadro's number in dimensional analysis. It just kind of depends on what your question is asking you for. And so you've got some practice problems here. Make sure you're converting the name to the formula correctly. And the first several ones have the answers in parentheses. That way you can check your work and kind of build up your confidence a little bit.